Okay, guys, so our next topic is talking about cycloalkanes or cyclic alkanes, as you can call them either. These are hydrocarbons that form a cyclic or a ring structure. So in general, missed an R. In general, you take your same carbon chain, but now you're just going to connect the carbons so they make some kind of ring. In order to name cycloalkanes, we add the prefix cyclo before the name of the alkane chain with the same number of carbons. So for example, here we have propane. Let's actually change the color of this. Here we have propane. And then when we have the same number of carbons, but now they're connected, it's going to be cyclo, and then the same name, propane. So you can see 1, 2, 3 carbons, 1, 2, 3 carbons, same name or same number of carbons, but now in a cycle, cyclopropane. So we have little questions over here. What are the molecular formulas for propane and cyclopropane? So I'm going to write underneath here what they are. And if you draw out all of the hydrogens, the easiest way to get to your molecular formula, you get C3H8 for propane. And then for cyclopropane, you get C3H6. So how does cyclization affect the number of hydrogen atoms? Cyclization makes it so that you lose 2 hydrogens, or 2 less hydrogens. So you'll notice that that's a common motif around when you cyclize things. So all alkanes, cycloalkanes, will have 2 less hydrogens than their parent alkane chain. So we have some examples of some of these, and you guys can fill this out on your own as well and try it out and then come back with me if you'd like to. But we're going to put the structure, the name, and then the chemical formula for each of these boxes. So first up here, we have butane. So but is 4. So we have a carbon chain that is 4 carbons long. We already have its name here, so we don't need to do that, but its formula is going to be C4H10. If you draw out all of those hydrogens throughout the molecule, you get to C4H10. Okay, and then let's do the cyclized version. I was about to say the answer. So the square shape is the name cyclo with our parent alkane chain. So it's cyclobutane. Its chemical formula, you can either subtract 2 from your original chemical formula for butane, or you can draw out all of the hydrogens on here. And you find that you have C4H8 as your answer. Okay, let's move to the right and do our next one. We're going to do 1, 2, 3, 4, 5 carbons long. That means the name is pentane. Chemical formula is C5H12. Okay, and now we're going to go into the cyclized version. So we're going to make a shape that is a circle but has 5 points. So not a circle, you know what I mean? So it's going to be a pentagon. So we have 5 points, 5 carbons all connected in a circle, in a cycle. So our chemical formula, -2, is C5H10. Okay, and our next one is, let's count our carbons, 1, 2, 3, 4, 5, 6. This is hexane. Chemical formula C6H14. We now have cyclohexane as our name, so we need to have a hexagon. So earlier when I said you were going to be drawing a lot of hexagons, this is where it starts. Just letting you guys know. C6H12 is that answer there. Okay, and then our next one, octane, that means 8 carbons. Let's do orange. Start with 1, 2, 3, 4, 5, 6, 7, 8. I'm going to number those just to make sure. Beautiful. And then our chemical formula, C8H18. And then we have our stop sign here, an octagon. It corresponds to cyclooctane. Chemical formula, C8H16. Great job, guys. And our last slide for this video is we're talking about the shapes of cycloalkanes. So as you notice, we've been drawing all of our cycloalkanes flat, so just like their geometric shapes. However, carbon is still tetrahedral. So in a tetrahedral molecule, you want 109.5 degree angles, where that's not always possible with cycloalkanes. And there's 2 specific major exceptions are cyclopropane and cyclobutane. So as you notice, their natural angles are less than 109. So there's no way that they can get there on their own. So we still draw these molecules flat. And for the purposes of this course, we will draw them flat. So just as an example, this molecule, cyclohexane, actually looks more like this, where you have all of your carbon atoms. Which one do I want to do? Like, for example, here, all of those angles, the carbons automatically relax into the shape so that they can have a 109-degree angle between all of them. So if this shape is kind of confusing you a little bit, imagine where I'm bolding right now. That part is coming out towards you. We call this a chair conformation. And for the purposes of this course, we are not going to worry about drawing these in 3D. We will just draw them flat. So don't worry about this. I'll go ahead and write that. Don't worry about drawing it this way. It's kind of tough to draw it like that. So that is our intro to cycloalkanes. I hope you guys got it. And if you have any questions, let me know, and I'll see you next time.